Okay, so we're back in the program in which we go down in the tutorial hell of going through this ziglearn.org chapter 2. So we're here. Last time we talked, we were here trying to learn how formatting works in Zig. So we learned that we can say something like this to show a number. Compiling this gives us error. What error? Command executed. What happens? Locator. Oh, I don't know what the locator is. We need a std allocator or just allocator. What's allocator? Memory allocator. Yeah, this should work, no? Yeah, it's a pointer to an allocator. Tried to clean this up, but messed up. So allocate is a pointer to allocator. This is in the general purpose allocator. So this is our little boilerplate that we like bring along with us everywhere. There's always a little bit of boilerplate in Zig because we want to see what's happening. This is our allocator. This is our the actual thing that gives us the allocator, and we defer and we find the leaks. If we really want to find more memory problem, we could show this. But this is what we're looking at now, and we see that we can see this, and we're here now. We're really not skipping anything. We go through this page very slowly to understand what's happening. So C formats a byte into an ASCII character. Okay, so C. So that's another one I didn't know about. C. So if we give something that's a byte, 66 will give us, it looks like B. It's gonna look like B because, yeah, C is character, so ASCII character. So if I give something bigger than ASCII, like more than this will give us the last ASCII character, so it won't crash. But I guess that so that was a space. Interesting. So I guess this will crash. Will it crash at runtime? No, it crashed at compile time. Integer larger than 8-bit is an ASCII. So that's the fun part with the formatter. It's all it verifies at compile time if it works. So next one is this. What's this? Format int size deck. Format fmt int size bin. Output memory sizes in metric and power of 2 base notation. Huh. Really? So I can say something like std fmt int size deck 1, and I just say whatever, nothing, and it's gonna write this 1 byte. 1 byte. Returns a formatter for EU64 value representing a file size. Interesting. Size binary is the same. So if I say 1, 0, 2, 4, that's going to give us this number. So number of kilobytes. But if I say bin, it will approximate it. I know, it's just like in binary or decimal. Okay. Times. Is that a thing? 3? No. So in bin, that should give us 1 gigabyte. 1 gigabyte, but in decimal, it will give us some approximate thing, gigabyte, but with an I. So the I means it's in binary, and no binary, it's this. But that's almost the same, so don't really care. Binary, octal, okay. In binary, it's just 254. Binary, like this. What will this show? It should show in binary this number, what it is. Okay. And in octal, really? Don't really care about octal, I guess. No, don't care about that. Okay, sorry, that's extremely boring, the formatting part. So hopefully, I'm not sure what happens next in this tutorial, but we'll see. Pointer formats, we can see pointers. Int to pointer. Int to pointer. So we cast to a pointer to U8 this fun dead beef, which is some easy to remember number in hexadecimal. So the formatting, the way we format it is like this. So this is how we see pointers. And this will show the actual, this is the way we see pointers with an at here, dead beef. Int to pointer. So no definition for that, but okay. Put floats inside scientific notations. Okay, that's easy. Guess that's not too complicated. Let's just try it again. I think we've tried it once. Some number. That's scientific. That's going to be easy. Yes, scientific. And then S outputs strings. So remember that a string is this. Is it this? It's not this. An actual string is no, it's this. Was it a pointer to that? I don't know. This. So if we want to see this as nothing, he will complain. He'll say, tell me, please, we need either this or this. So if we say S, it's going to say the word hello. But if we say we want pointer, we'll see the actual address that we got. The address of this. Multi-pointer, sentinel value of 0. So null terminated multi-pointer of const U8. Advanced formatting, position, specifier, fill, alignment with precision. Ooh, that's intense. Position, index of argument that should be inserted. Type specific dependent formatting option. Fill, a single character used for padding. 1 or 3 characters. These are for left, middle, or right alignment. Width, total width of the field. Precision, how many decimals? Okay, so if we try this, A, B, what? This string and this string, but formatted with 0s, then 0s again, and 1s, That's what? Oh, you can specify which argument you want. So 0 says, give me the 0th one. And this give me if the 1, the one at index 1. So this is this one, this 0, and this 0 is corresponds to this one. So we'll see AAB. AAB. And use this, okay. AB. But that's weird. So if I say, if I don't use the second one, it's going to complain at compile time that I'm not using it. Is that it? Yes. Unused argument. If I try to go elsewhere, also going to complain. I'm going elsewhere. Too few arguments. Nice. Then fill alignment with, okay. We try this. We try to do this. I S tag space 5. Path. So aligned to the left. This high here, aligned to the left. Padding to 5. So if, and this is the character that I put in the padding. So if I say A instead and pad to 10, so there's going to be some A's to fill the space here up, so that this is going to be 10 length. The high will be to the left string here, will be to the left, and then there's A's there. So the padding goes to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Interesting. And if I go to the center, like this, I should be in the middle of the A's. Wow. 3 on this side and 4 on the other side. So it's not exactly the middle, because 10 should be a, depends on the size of this and this. So you can't be exactly in the middle. Okay. So that was, yeah, this looks like in the middle with underscores, looks like this. I, and then to the right with this will look like this. Okay. Using a specifier with precision, d.to. So when we print a number, d, and we want to print this number with lots of decimals, it looks bad. It looks like a large number of decimals. But if I say, so the syntax is this: d semicolon dot 2. Colon dot 2 like this. Give me 2 decimals. Okay, let's try to remember this. That's fun. Just 2 decimals. And that's it. End of chapter 2. That's beautiful. So what's next? What's next? It's build system. Zig provides 4 build modes. So like to learn about the build system, I think it's going to be fun, but we don't know anything about that. But I know that there's this, but someone told me that there's, like in the Zig news, there's a better Zig build explained tutorial. So the Zig build system is missing documentation, and for a lot of people this is a killer argument not to use it. Others often search for recipes to build a project, but also struggle with the build system. So this is a better tutorial, I think. So let's go through that. So just to make sure we're like ready to understand what's happening with the build system, so we have our project here. So this is what our project looks like here. And we have this command line here, so we know we have everything. command line looks like this. And what we've been doing from the beginning is we have this, when we launch, we run this task build. So that's what happens when I press F5. This is what we do. But the first thing that happens is I call this task build before launching with GDB with this thing that makes it I can debug. And then the other thing is this. So task, that's the build task. Type shell, and the command is zig build. So I guess here, what I'm actually doing is just zig. And if I do zig build run, it's gonna run. So let's forget about VS Code tasks and everything. So we're gonna do it in the terminal now, just to understand more what's happening. So let's go back to our main. So let's just print hello world. And so like this is what I'm actually doing. And now we're gonna not do F5. I'm just gonna go here to see what's happening. But we're gonna look at the build file. So when we do the command to make a new project, this is what happens by default. Like that's the default build script that I got when I did at the beginning of my journey through learning Zig. I got this build.zig. So this is exactly this. Yes, this is this. Standard target options. Okay. Person running Zig build to choose what target to build for. Okay. And standard release options. Okay. So I guess it means that I can say something like Zig build. Should I put arguments here? Like, there's like, yeah. Like this, arguments, can put arguments, Zig run, Zig build. Should I say something like build arguments like this, really fast run? Is that a thing? No. Just like this, or like this. It's not 0, it's O. It's 0 like this, or O, O. Click build, O, release fast. Target, build options. How to build in release? I don't even know how to build in release. Fix and build and D. It's not O, it's D. D, release fast. Just D, release fast. Release fast. Huh, this worked. And then I can say run right away. Boom, hello world. So that was the fast version. So I guess this won't crash if I do bad things. Let's try to do something like var boom, which is a U8 equals 255. That's the biggest one. And I say just boom plus equals 1, and it's gonna explode. Try to print this. Hello, boom. No, what will happen? So now I'm actually just pressing F5. So I actually did. So I get a crash. But if and this is with like the default, which was probably debug. So if I do it here, what, don't do that. So if I go back to my terminal here and I do, oh, that was the command I just did. So you see it was, oh, sure. So if I do this instead, boom, 0. So it looped around. But if I do the debug, run, no, debug does not exist. So it's just nothing. So just zig build, run, like panic, integer overflow, and so it's the release fast. And run. So we looped around, got 0 because I wasn't released fast. Interesting. Okay, so that's the first time we actually compiled and release. That's fun. We know how to compile and release. So there's going to be release safe, release small, release fast. So I guess we're going to either debug or release fast, or release safe. But release safe until it gets to... I guess we're going to just use debug and release fast, basically, until it becomes too slow. And then we switch from debug to release safe, unless we have big problems. And when we're trying to debug, we go back to debug. By default, it should be release safe, I guess, when we have problem, when we have, like, when our game is actually running in an actual map. So this is debug until it becomes slow, and then we switch to this. And we ship this, obviously. Never care about this one, because we're on a console and don't care about that. So I guess what we want to do is not look at this, because they said that this is a bad tutorial, and we'll look at this one instead. Okay, so now let's so this, they're gonna explain what this is. So that's our goal today, is to look at this build. Where's the build? Where's the build? Well, here. So build. Basics. The core idea of the build system is that Zig toolchain will compile a Zig program with export a special entry point. We'll compile this program that has this function. Okay, so let's forget about, like, let's remove the comments first, just to keep it really simple. And let's comment out all this and not look at it anymore. Just now, if I should say just Zig build, what happens? Nothing. Zig build run, that's not a thing. Oh, like we still have the problem of this. Let's not explode. Unused function parameter builder. Okay, so our build function is broken because we're not using this. That's good. So that's the first thing, is this. Let's understand what this is. Each step has a set of dependencies. Okay, let's like really read this slowly. This function will create a directed acyclic graph of build step nodes, where each step will then execute a part of our build process. Each step has a set of dependencies that need to be made before the step itself is made. As a user, we can invoke certain named steps by calling Zig build step name, or use one of the predefined steps. For example, install. Okay, that was a lot of words, but I guess I understand a little bit. To create such a step, we need to invoke builder step. Okay, let's look at the code instead of words. So what's happening is const named step. So we make a step, and we do it by saying b step. But first, let's like rename things. Builder step. So, and we have a step name, and this is what is shown in help. Okay, and what is this? Can we go there? Yes. It returns what? It returns a step. What is a step? It's this thing here. And a step. Where are we? We are in a file build.zig, which is in there in std build.zig. So that's the whole file for build. Called step. Step, which returned a step. Okay, so we return a step. So this is a step. Like step. So that's not a thing. So we need to do something like std build dot step. It's a step like this. So we have a name step. Okay, that's it. So we can just like, we don't care about it, so we just send it into this little void thing. Like, don't care. It's actually a pointer to that. Pointer to step. So that's interesting. What is a build step? Oh, what? We crashed. Why did we crash? I didn't save this. That's not supposed to crash. Did I save it? I did not do anything. I did not compile the thing. So that's why, like, it's still there. So the run is still there. So I guess when we run the old thing. Okay. So let's just do what, like, can I just, like, where am I? Here. No, here. Can I like control C or something? This terminal is broken, so zig build. Okay, we have this. Can we print stuff here? Print. Print. Also std the bug print. I want to print the state. This thing. Name steps. Oh, sorry. That won't work. So I'm allowed to print stuff in there? Am I? Ooh, I'm seeing something. Debug console? No. Output? Can I see things? Like, what is this terminal? This terminal is broken. Like, let me kill this. Can I kill this terminal? Yes, thank you. Okay. Guess I should stop. Let me bring this back up for 1 second, just to make sure. B. Who is the builder? Let's go back to B. Don't actually care too much. So we have a name step. And now we'll be able to see the step somehow. So here, like I'm here. Oh, hello, boom. Okay. So I'm here and I see zig build help. Build help. Boom. install step name. Whoa. Step name. Wow. I literally see like that's not what I wanted to do. I just want to see the help, and I'm seeing this step. So let's see what exactly happened there. Here, come on, like this, clear this, and I see zig build, and I see my little thing that just got there. This is what is shown in help. Install, uninstall, run, and my new thing that I added there. A new thing. You can do whatever you want, and I can print stuff. Okay, so let's put a breakpoint there. Like, that's the problem. Like, can I put a breakpoint? I'm not able to put a breakpoint there. Because I'm not actually like running this with the thing. This launch. If I want to launch, which program? Like, I want to run like actual Zig program instead. Like, I'm not sure I can actually debug this. Like, I'll need to just put prints. Like, there's no way this breakpoint will catch anything. So yeah. So we're here. We understand that we have a build step now. Okay. And what can we do with that? Note that this step still doesn't do anything except putting that nice little entry in our Zig build help and allowing us to invoke Zig build step name. So we can actually call this. So let's see what happens. So if I do, like always, like redoing everything, like why? Okay, let's like forget about this. Wow. Stop. And come here and just Zig build, and we do, oh, let's just call it, whoa. It didn't do anything. So name step needs to do something. So can we just give a lambda or like some function to execute or something? What's a step? ID, name, make function. So I can give it make function. Dependencies, make function. ID is one of these, custom. I guess I can run any like function probably, but I need to, so step here, builder, name, description, step, set preferred, step info, step level info, description. Not clear how I can do like random custom thing in a step. Okay, same interface as mem allocator and requires implementation of a single make function. Make function. Now we need to build ourselves a nice little Zig program. Compiling the Zig source, I guess that's the goal. Compile an executable with the build system. The builder exposes build add executable. Create us a new libexe obj step. Okay, so add executable is this function. Sorry. Yeah. Okay, let's just type this. So let's forget about our name step. Just do const exe equals b add executable. Call it whatever, and the file name is source main zig. This exists. It's right there. Source main. And what is it? Add executable. It gives us this thing. Huh. This is part of build again. Build. Steady build. What is this thing? Base ID step. Okay, so libexe obj step. So it's one of these three things. So it's a step that gives us either a library or an executable or an object file. Okay. And there's all this. Oh, so many things. So many things in there. Whoa. Whoa, 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 whoa. That's like a lot of things. So many things. Like lots of things to set up. Wow. Okay. Whatever. Is it smart to call it whatever? I should call it like nouveau, because it's what is called for launch nouveau.exe. Like this will not compile because not using it. Unused local constant. Okay. So let's not do that. Actually, let's actually compile step. So exe is an executable, and we're gonna say that it const compile step. So that's a step. So exe is not a step. This is not a step, but contains a step. It contains a step. So it's like subclass of step or something. Compile step is b.step compile. Okay. Compiles src main zig. And we say step depends on compile step is, as we know, this steady build step, and we can say depends on, like, why don't you know what this is? Depend on step other. Depend on step other. Yeah. So that's the first, that's what you are, or you are. And the other is I depend on comparison depend on step. So in order to be able to compile, like, it feels backward to me. Like, I guess to make an exe, you need to make the compile step. So I guess the exit depends on compile, but it's the other way around. So yeah. Is that it? So like we have this and that's it. So like now we can call this. Can we say that? Can we say the zig build? Well, we see compile. Whoop. Unused local constant. Yeah, that's true. Let's just say I don't care. No, not F5. Stop doing F5. I want to do zig build help to see that we have our little new command. That's not, why is it still there? Yeah, it's there. So I need to kill this terminal again. Build help. And now I see compiles this. It's really fun that I can click on things anywhere in the logs. Wow. Okay. And dependencies append other. So that's the dependencies of compile step. It feels very backwards to me. The executable will depend on compiling this, no? This step in the exe. That compiles us our main previously created with zig init exe. We added a few lines here. First of all, exe will create a new lib exe obj step that will compile into a file called fresh, called nouveau, or nouveau.exe on Windows. The second thing added is compile step depend on. This is how we build our dependency graph and declare that when compile step is made, exe also need to be made. So when we decide to compile, we also want to make this. So it's going in this direction. So we do this and then we do this. And depend on actually means and then do this. So it should be called and then do this other thing. That feels very weird. Let's see. This is how we build our dependency graph. Exe also needs to be. Okay, we can check this out by invoking zig build, then zig build compile. Zig build compile. Okay, let's actually do this. Zig build. The first invocation will do nothing, but zig build compile, which is our new little thing, this word here. Boom. This did something. Did it? Let's kill all we have. Like let's destroy this. Delete. So what happens when we do this? Zig build compile. Boom. It made something. It did a zig cache with all this in there. This and this. Oh. There's this and this. Build exe. Wow, that's the executable that this made. And this is the actual executable nouveau. So it's there now. So I can actually run it like by saying directly like this path. Directly. Boom. Boom. Zig cache. Like literally, like try to run nouveau.exe. Boom! It did it. So we can actually run this, the executable that we just made by doing this executable. Huh. And if I do it again, like now the time changed, so we're not at this time anymore. So if we run it again, you'll probably see that it's already compiled, so it did not modify the file. Did it? It did not. But if I change my file, I say just space like this, book, save this, come back here, compile. It's gonna change this. Yes, change the time of most of them, but it sees that the PDB did not change. So that's interesting. Didn't have to write the PDB again, but all of those did actually change. Okay, that's interesting. So we're here. This will always compile in debug mode for the current machine. So for first starter, this is probably enough. But if you want to start publishing your project, you might want to enable cross-compilation. Cross-compilation is enabled by setting the target and build mode for our program. So we're going to do something like exec set build mode release save. Okay, so we save fast here, and we come here and we do the thing that we know will explode, which is like adding a big number to the biggest number we can have, and we do this. So I can like save this, and say build compile. It did probably change the hash here, did it? It's gonna do, oh, it's a new one. It's a new one here. That's the newest one. So I guess it's better to just call run, zig build run. Is that a thing? It won't actually work because we don't have anything. Cannot run step run because it does not exist. We didn't actually make the run thing. But we can execute this one, and it's gonna wrap around because we said release fast. So I'd say this. Boom, it wrapped around. But if I say so like in the cache, there's gonna be like multiple versions, I think. Okay. Then set build mode and then set target. Set target would be one of the target, but I don't actually care. It's gonna, like, I won't compile for like Linux just yet or other things. The cross target you want really configurable. Luckily, the build system provides us with two convenience functions for that: builder standard release option, builder standard target options. So instead of doing this, we do const target standard target options, which is this std build standard target options args. No, really? It's not a thing? Come on, give me this. Standard target options. Come on. This. It's this. It's part of the build. Whitelist, cross target, default target. Cross target is this. Come on. Give me cross targets. Yes. Ha! All the architectures are here in cross target. That's how we see a cross target. CPU model, native, baseline. Okay. Whatever. So instead of saying this, I say this because I want to know what this is. And what does this give us? It gives us a cross target. Target is std build plus target equals this. And exe we set this target. So exe set target. Okay. Okay. So that because of that we can do the parameters on the command line to give all these things instead of doing this. So that's because we don't want to do this. So instead of doing this, we say make a target and set target. No, it was build mode. So target is the architecture and build mode is optimization mode. Okay, so now we say mode. Let's be standard release options. Standard release options has no parameters. So contrary to this one, there's a big argument here, but there's none for this one. If you call this without first calling set preferred release mode, then it gives the user the choice of what kind of release. Okay, so standard release option returns a built-in mode. Really, built-in mode. That's a new thing. Mode. Mode. Built-in. Oh, give me built-in. Built-in is part of build. So std build. Built-in. Really? Ah, messed up. Cross target is private. Is private. It's private. Look, cross target. Where is it? Zig cross target. Huh. It's just zig. Really? I just do this? Ah. Cross target is zig cross target. It's private. But it won't work. So I don't like let's do this and then try to print the type of this. Type of again. Oh, I don't like this. Oh, come on. Where is this? It's right there in build. It's pub. Build. It's right there. Why? Sure. Like, what is this? Build. That's a thing. That's build. You can see this. And I don't understand why no member called steady build standard target option args. Has none of these. So where is this? It's this. This is where. This is right there. In builder. Steady build builder. Wow, voila. Oh, still a 5. Built-in is private, so it's this one. Can I go like built-in like this instead? Did not save. Aha. Okay, standard release options returns built-in mode. Built-in mode. Yes. That's good. What's this? Built-in. Oh, it's different. Guess we need now to do different things like once built-in equals import built-in like this. And so we have built-in like this directly. Ah, still a 5. Expected type found built-in mode. Oh, I'd like to see what this returns. This returns a built-in mode. Ah, mode. It's M. It's a type. That's true. It's supposed to be a type. Yes. Now, are we good? Oh, come on. I didn't save. That's why I need to. Yes, F5 is not too bad. Oh, come on, dude. You need to give me mode. It was std. What is this? Built-in mode. Built-in. Where is it? It's this. Mode. Built-in mode. Mode. No definition for mode. Really? In there. There's mode somewhere. Can you give me mode, please? Yes, there's a mode. This is it. It's right there in built-in.zig. Okay, built-in mode. Built-in mode. Right there. So my build is there. No. Come on. Give me my file. Where is it? Built-in mode. Built-in is private. What? Clear. This is supposed to be saved. Built-in is just this. This works, right? Container built-in has no member name mode. Really? God, there was. Built-in zig? Not zig? No, that's not. The built-in is std built-in. Really? Come on. New localization. No, okay. That's it. So now we have it. It's because we need to do this. So it was all right, like all along. Just this. So now we just set the mode. Say set mode. Mode. Oh, sorry. The reason why it's long is because I want to see like what is what. So I wanted to be able to, yes, please give me the modes. That's what I want to see. Code model, blah, 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 mode, blah, blah. Atomic, I don't know what this is. Built-in. Oh, that's lots of, there's a lot of built-ins. What is a built-in? I don't even know. What does this mean? These are all deprecated, okay. Subsystem, stack trace, global linkage, atomic order, reduce up, calling convention. Wow. Okay, source location. Ah, source location. Interesting. Okay, are we good with that? Set mode, come on. What's that mode? Set build mode. Okay. Compile step. This is still like this. Now we have a target and a build mode. And it works. It just wrote cross target. But why don't you just like target? Private? Like what? The build? Target. It's right there. Why don't you want to give me, want to see what is the cross target? Still private. Private. Like I'm able to have it, but I can't know what it is. Probably because this guy like returns something that we don't even know what it is. Okay, so let's not try to see what target is, because it looks like it's private. Okay, let's agree. Don't really understand this. Why can't I see this? So mode, okay, so we have target, that's the architecture, that's the mode, and we set that on the exe, which is the libexe obj step. Okay, then compile step, and we see compile step depends on exe, and depend on means when I compile, I also want to get an executable. And it goes in this direction instead of what I think the word depend on means, but let's not think too much about that. So zig build help, you will see more things. So this will work now. Compile, okay. Oh, I didn't save. So this will work. We'll compile. We'll be happy. That's it. And just zig build help. We'll see more things. So because of this, we see the project specific options, these. Okay, let's like look at this for a second. Let's clear this. I really hate that I clear and I can still see it here. But I guess it's okay. That's how the clear works. But yeah. Can I see a different color for this? Like there's no parameters, but for the terminals, if I see colors in terminal, it's like a bad terminal. Like there's no colors. PowerShell. Can I see a different? terminal. So if I didn't do that, like this is what I got now. I have this compiled, and then general options, this project specific options, advanced options. But if I did not say all these two new things, these two, save this, and I say give me help again. Now there's gonna be some things missing. It's really just the steps, general options, project specific options, none, and advanced options. So the project specific options, that's the easy way to make them. Standard target options. It's really long. Like the compiling, like analysis, semantic analysis, that's too long. Like what's happening there? It's because the build file changed. But when the build file doesn't change, it should be fast. Yes, very fast. Thank you. So we see this. It's true, we see exactly this. The first two are added by started and target options, yes. CPU and target. Target CPU, features to add or subtract. Like for example, this thing, Atlan FX. And target, that's the name of a target. I think that's the target I'm on, I guess. And release save true, release small, we could decide this. We want to look at the size and see if that release small will get smaller. I want to try that. So if I say zig build compile and say the real with nothing, so that's going to be a big debug thing. So we can look at the size of, like, what's the latest thing that I did is this one. So there's an executable. No, it's not this one. It's let's try to compile again. So I go to my main, just say something. Let's see. Whoop. Zig build. Oh, does not exist. Okay, okay. I'm cool with that. Let's say this instead. Now this time will change somewhere. Did it? Yes, this one. So we have this. We can look at the size of this now. What's the size? 419 for a debug build. Now I can say what? Say the release small. Will it be smaller? Do I have another one? I guess this one won't change. Now in here there's a new one that just appeared. This one is very small, 25. Wow, this is small. And now release fast. That's gonna be another one that's gonna appear. Boom, probably this one. Oh, release fast is even smaller. No, that's not possible. Okay, let me kill all this. Zig cache. Let's kill the zig cache. Nouveau zig cache. You're out. Delete. And try again. Release fast. And then let's look at this. We just made this guy, which is 7 kilobytes. And then small. So we want to be smaller, and you're gonna be bigger. Okay, that's weird. It's very weird. Probably because when you want to be small, you still need some you still have some overhead. So for a small program, release fast is bigger, is smaller, because overhead probably of trying to be small means to need to have some overhead to like make sure that the rest is stays small. Maybe we'll see. As you can see, for a Boolean option, we can have yes, I knew that. That's what I've been doing. We still have the default invocation is still not doing anything. Let's change this, because when I do just zig build, if I kill again this guy, you're out, delete. If I say just zig build again, this does nothing. It builds just this program, which is the build.exe. That builds the application is the actual executable that builds. So this program here, but it didn't do anything else. So nothing happened else than making the build program. So what happens? Installing artifacts. To install anything, we have to make it depend on the install step of the builder. This step is always created. We can access via builder get install step. Get install step in the builder. Install exe, add install artifact. So it's a step that's always created. So I made a step here. It's called the compile step. But there's another step that is always created without me knowing. And I see it by doing help here. I'm going to see there's an install step here. Copy build artifacts to prefix path. And it's been made, and I can access it with get install step in the builder. Probably get install step, self install TLS, top level step, uninstall. It's a top level step, which is a base ID top level, a step, and a description. So like this is literally like inheritance in Zig. You contain your parent. That's what an inheritance is. You want to see like your parent data inside yourself, you just put it there. It's like inheritance without problems. Just put your parent inside of you. It's beautiful. That's the type of inheritance we should have learned in school instead. You just compose your parent inside of you, and that's it. If you want to do polymorphic inheritance and like polymorphic things, you just like do it, but without having all these magical things happen on in your back. Okay. So we want to do this now. So what is this? So let's forget about this first. It's like the exe is still not like used. Oh yes, I guess it's used, so we don't actually need that. So it looks like this. So let's forget about this also. Let's keep it simple. We have this exe. Compile step depend on exe, and that's the only thing we have now. So now instead we keep this exe add executable. That's this install exe. So we put it there. Really? Let's install exe. So we install the executable. b.add install artifact the executable. Add install artifact will return an install artifact step. Oh, install artifact step. It's an install artifact step. What is this? What is this? It's right there in build. In there, is it public? It's public. I should be able to say std build install artifact step. Oh, I did F5. Sorry. it's gonna do like what I want. Unuse local constant install exe, obviously, yes. And then do something with it. B get install step. B get install step and on install exe step. Oh, install artifact step has a step installed there, and the B get install step, this thing that we were looking, depend on. So I guess I need to make a drawing because now my brain is broken. Do I have a like paint? So I want to please be smaller. I want to do something like brushes. Yeah, so steps. So we have this guy. What? This guy depend on. So I guess depend, like, let's make it like this. Depend on install exe. B install step depend on compile step depend on exe. That should not be difficult. It's just like do this, like depend on exe step. Okay, that's depend on. Okay, and then there's another dependent, is this one, install step. So we have B get install step depend on this guy. Wow, come on, dude. Install step, let's see, which is this. So this install artifact step has a step in there, so I need to depend on a step and get install step. Add install artifact. Add install artifact gives us a step. So we're just like not actually building anything now. We're making a program that will compile stuff. So this actually makes a program. This is a program that builds. It's not building as I'm executing this. This is the process of creating a program that will compile our code. This is crazy. Like, it just breaks my brain. I'm not smart enough to understand this thing. Well, okay, let's just finish this. Let's finish this. So, does this work? Build. So if I say build now, it will do things. Yes, it's doing something. And it's making a new directory, is it? The projects, blah, blah, blah. Yeah, it made this. It just did this. And now we have our executable here instead of just in the cache. It's in zig out. So this one got copied. It's this one got copied over there in zig out. So now we can run it by saying just zig out bin nouveau exec. Panic, integer overflow, because I'm in debug. Beautiful. Because of this. Okay, anyway, so now we can just build easily. I literally say this, but I can't I can't do run yet. There's only thing missing because there's no run command. I have this, I have install. So I did two things. I compiled it and I installed it in zig out. That's what install means. Just make zig out. In zig out, I guess we could like install step, depend on install artifact. There's no like options. Artifact step. Does this dir install dir create. I guess we could change the install dir somehow. Push installed file make. I guess the install file, like, there's no options in there, so it's not clear how to change the output directory, but don't actually care too much. So this will now do several things. It will create a new install artifact step that copies the compilation result of exe to prefix bin. So what is prefix? No, we'll talk about it. As the install artifact step implicitly depend on exe. Okay, this one it depends on exe. Like as we do this, probably it says like depend on exe. As you create this, it's gonna say depend. Probably, yeah, you see, here it is. This is what they mean here. Depend on exe. Yes, it's this. We'll build exe as well. We'll make install artifact step, then we call zig build install, or just zig build for short. So now what we actually want to do is build install, which is exactly the same as zig build. It's weird that we don't see like this. It's kind of sad. I don't really care, I guess. It's not like it's very important. Registers the output file for exe in a list that will allow uninstalling it again. Now invoke zig build. You can see it made this. Yes, that's what I did. You know, install the artifact. Like let's say if we try uninstall. Install. Did it delete thing? Yes, I know. It did not delete anything. Zig uninstall. Zig build uninstall. Ah, it deleted it, but not the directory. We don't like deleting directories for some reason. Okay, now you can uninstall the artifact again. That's what I just did. So delete all the files, but not directories, okay? As the install process is a very common operation, it has two shorthands to make the code shorter. It's not too long. I don't know why they want to make this shorter. That's fast. They want to, it's just this, exe install, and I guess this is the shorthand to talk about, and then run. Yeah, I forgot about run. So instead of doing install exe, add an install artifact, get install step, depend on install exe step, all of this can be replaced with executable, just be install artifact exe, be install artifact exe. So this replaces this. But I like the big one. Like I'm not smart enough to understand all these. It's same as this. Install artifact. Install exe. It's gonna like install artifact. Let's look at this. It's gonna be exactly this. get install step depend on self add install artifact step. It's literally this. This is this. Add install artifact step. Add install artifact step. Or even shorter. Exe install, because the exe knows about the builder, because the exe actually knows the builder inside of it. Like, yeah, we have a pointer to the builder, so you don't actually need. So this actually calls builder install artifact self. Builder install artifact self. Yes, just exe install. So it sounds like just we install now, but no, we're making a step that we can then call. That's what's like messing with my brain a little bit. Okay, so let's not do that and just do this because we want to see things. Like this is what install step, like I want to see like this step, the install step. Install step, like the one that they say is like internal install step, like this, the install step that isn't there like by default, like top level install step is in there somehow. It's get install step, it's a step like this. It's an actual step. It is get install step. And we can say we depend on this. So install exe, it's install artifact exe. This goes in there, and this goes in there. So like it makes sense. It goes inside by with using this, and then depend on, and then there's another thing here that's like independent, but it depends on also this. So this is the only thing that depend on this. This one depend on this one, and this one is add install artifact. Add install artifact, it implicitly depend, as we saw, this thing depend on artifact step. The thing we pass, the thing we pass, it's like depend on this. So this depend on this, like this one also depend on this. So this one depend on this. That's this. Depend on this. But install exe, it's like depend on this. It's implicitly depends on this one. On exe. install implicitly depend on this one, but this one, now we see that it goes like this. This is the same. Depend on this depend on this depend on this, and this depend on this also. So it's really like, it looks like this is actually this, and it's actually this, and it looks like this. So it says depend on this, but it's like when you want to make an exe, you need install step, top level step. What is this? And then, okay, let's forget about that. Running build applications. For development, user experience and general convenience, it's practical to run programs directly from the build script. So usually exposed via a run step that can be invoked via zig build run. To do this, we need a std build run step. Okay, so run step. So this is, maybe we should put that after. Oh, no. Okay, let's put the run after. Just say const run step std build run step create exe builder run go. Exe builder, like it's the builder. We actually just saved it like self name. I don't know, like the builder of exe is not me, it's not this. I don't know. What is this returning? A run step. Okay, that's a run step that happens in, oh, directly in run step. You're right there. It's the file run step. std build run step. Yes. Okay, run step. And then that's a run step. Const step. It's like, what is this? It's really crazy. I make another step, call it run, and I say runs the executable, just to see that it's me, like I'm actually saying that. And this gives us this step like the other one, like this. It's another step, and now we say that this step depends on what this step depend on run step. So we made a step like this from the builder, and it depends on this. What if we say just run, like it's build run, but like this, how does this knows that we need to build before? So I guess we could also shortcut this. All of this can be run step create, exe run. Exe run. Okay, so let's just try this. Not uninstall. What I want is actually build run. Yes, that's okay. That's what I wanted. Don't do that. Try this again. Zig build run. Something happened. Again, I saved. Please. Zig build run. I saved this, right? Should I like clear, like zig uninstall? Will run again? Really? Like you don't see that it's actually okay? I saved this, right? I don't understand. I said this. C builder. So the shortcut for this is just this. Okay, exe run. Okay. Same as this. Oh, and zig build run. No, dude, if you need to like give me something there, like you don't want to like build it again. You need to kill this manually just to make sure, because it looks like the uninstall broke. I think it's not making the out. Yes, it's making the out now. Is it because what I just did? Like it couldn't be const? That would be sad. No, it's not the reason. It's still saying index out of bound. Run step make. Create exe builder. Step. B step run. Run command. It's run command. Okay, let's do it like this. Const run command. Exe run command step and it's the opposite. Oh, we need to depend on, like, if they forget to say that this needs to depend on the get install step and on b get install step, like this thing level install step, yeah, const this guy here. I need to, that's what I was saying, like we forgot to say this, the run command, let's call it command, and we need this like this, the run step, and now we still need like do run step depend on the top level install step. Why we need a pointer like this, this depend on install. So in order to run, we need to be installed. In order to be installed, you need to become to be install. You need to be compiled, but compile is in the other direction. But that's what I just did here. Run step depend on run command. And this one is run command. Depend on run command step. So that's what was there before the run step. Depend on run command step. And run step is this. The step. Okay. Run step. And then this guy. We don't. That's what we forgot. Needs to be level install step. This thing. Run command step depend on top level install step. Depend on, my god, my brain completely fucked. Exe run gives this. Yes, depend on. Yes, we need like this. Yes. Come on. Really? still broken. Like panic. Why? Why? There's no panic there. Like, I'm saving this file, right? Let's just... Can I please just zip build? Zip build run. Index out of bound. Why? We need arguments. So we need arguments to the program. So that's the problem. So that's what like we actually need to send the arguments. So we need to say the run step. This is this run command actually. Run command that depend on that we can't forget this. We need to do if the the run command add args the run step is called run command for us because that was like this here. So I just, and this was before this command step depend on install step, which is this. This is install step. Now good. This is gonna work, pretty sure, because we needed the argument. And come on. Why? Come on. Please, just let me build this. So with build, can I just run the program, please? Just like zig out, zig out, bin, boom. Yes, it works. Why are you not happy? Run. Maybe like they did not want to say this, so let's not add it. I'm broken, completely broken. Why? Still very, very messed up in my head. I don't understand what's happening. I know that this works, at least. At least this works, right? This one works. So what's the difference? It's the order of things, probably. The install. I need to understand what's happening here. Like, let's forget about this and just put this everywhere instead of this. Boom. And then this guy. And then this last guy. No more than that. I don't need this anymore. Yeah, this is the one we may have forgotten. Run command. Create exit builder. So we said it's the same as this. Okay, let's use this instead. So we said this depend on the install step. Okay, args, yes. This run step, boom, run the app. Maybe it's a question of, yeah, this was bad. This string was wrong. Like this. Come on, please, please, please. It worked. So this is stupid. So this doesn't work. Maybe it's like we need to not say this. Like he said that I can do that, right? He said I can do this. That's what I did, right? City bid read oh, art artifact arg. Add artifact arg. I forgot this. I said forgot to run command add artifact arg. That's what I forgot. Let's see. The argument of the run command is the executable. Yes, that's why it was crashing, because it didn't have the argument for the executable. And that's it. That's only that. That's the only problem. Oh my god, I just forgot this line here. Boom. Oh, why? Dude, come on. Maybe we don't need this one anymore because of that. Now it works. So this is actually doing this. Like, depend on, boom, this line. It was redundant. So this was like doing more things. It's like appending the args and then depending on it. So yes, so this is not good. We just, like, this thing here is the same as this. So we add the other arguments of the run command. So the first argument is what to run, and then the arguments here. And this is the quick version of all this. And this was brain. It's completely broken. So now we can run, and we're happy. Let's just forget, but yeah. Boom. Okay, so we're happy, I think, with that. That's enough for now. Yes, it's passing arguments, pass arguments. So you put this to pass arguments. Thank you, person who made that. Felix, XQQ, sir, Q something. Thank you, person. But it's still very complicated, I think. My brain is not good enough to completely understand why we need to do that. We need more examples and maybe more clear things. So I guess that's it for today. Thank you. Bye.